So we're going to start a new program. So what do I need to do here? Yeah, create. Yeah, good. Create new project. And what we'll do is we'll give it a, well, we're going to play around with it, but we'll come back here. We're going to give it the name testing because this is the station that we're going to be creating tonight. And then we'll create. And this takes a little while. So I'm going to pause the recording while it's doing. Okay, guys, what do we need to do next? Yeah, pretty much right down the line. We got to add the device, so we're going to configure the device. All right, so what do we need to do here when paying attention? Add a new device. And then we're going to add our PLC. And what PLC do we have? Anybody? Yeah, S7-1200. Yeah, and then the CPU. So what we're going to do here, yeah, but it's 1214. It's not a 1211. It's a 1214 DC DC DC. Now we can go this route, but what we're going to do is I showed y'all this the other night, and we'd have to get this information off the side of the CPU. Unfortunately, we have mounted our I/O module on there, so we can't see the information, even though I know it's this guy down here. But what we're going to do, and this is what's really neat about the Siemens, is that if you've got your PLC, so if I didn't have my PLC connected to my computer, and I was trying to write a program and then connect to my computer later, then this right here would be the option you'd have to choose. But since I'm connected to my PLC, I have my cable that we made the other night, by the way, and it's working great. What's really neat about the Siemens software is we can come down here to the very bottom and say unspecified CPU, and then we can add this guy right here. And this is really neat. And then we can click on add. So it's going to start communicating with the PLC using a MAC address. It don't have an IP address now, but it's going to go out there and look at MAC addresses that were assigned to Siemens. And it's going to go out there and see if it can find a Siemens PLC. And it's out there looking for it right now. So we'll pause it again because this takes a little while. So what it's going to do is not only going to find our PLC, it's also going to find the module that's hooked up to the backplane. So it's going to go out there and find that 8 DC DC 8 input 8 output port. We'll go out there and we're going to detect it, and it should come in here in a few minutes and let us know what it's found. And so this takes out a lot of our work for us because now it's going to go out there and look at our rack. It's going to go out and figure out if we've got any modules on here. And so this guy here, I think, can handle up to 8 modules, different types of I/O modules. So it found my device, and it should already have an IP. The first time, if we came out there, the only thing it would find would be the MAC address. But since we've played around with this PLC before, the PLC has already got this IP address in it. So we're going to go out there and tell it to detect. So if this is the first time, then I would have to know this MAC address. And where can you find the MAC address at? We know what the MAC address is now, right? We know what that is. How could we find that? It's that 48-bit number that's assigned to every device, Wi-Fi or Ethernet. And Wi-Fi is basically just wireless Ethernet. And also Bluetooth devices. They all use MAC addresses. And it's a 48-bit binary number The first 24 bits, which is B right here, this identifies who manufactured this this NIC, this network interface controller, and then this would actually identify the actual NIC that's inside the network interface controller that's inside the PLC. So we're going to go up here and detect it. It's found it for us. And like I said, originally a new PLC would not have an IP address yet, and you would have to look for the MAC. And what's going to happen if you've got a network that's got a bunch of Siemens PLCs out there, it's going to go out there and find all the MAC addresses, right? So that's one of the information you'll have to get off the side of the PLC before you hook any modules up to it, because it's on the right hand side of the PLC, just like it is on the Allen-Bradley PLCs. So we're going to detect this guy and go out there and see if it can figure out. It's going to assign, make sure it's got an IP address. It's probably going to assign an IP address to my computer to make sure that the computer's NIC and the NIC on the PLC are in the same subnet. So yeah, so this is my computer. See, that's my gigabyte network card. So this is my computer. And now the PLC and the computer are in the same subnet. We can look and see what it ends up assigning my my PLC. So I got my computer set up for dynamic IP. So we just basically ran a DHCP server that's built into. Now, if we were running Allen-Bradley, we'd have to run that boot. I can't remember what it's called. Okay, so see, it found it, and so it knows it's a 12. It knows it's a 1214, and it went out there and found this module, so it found it for us. Are we okay? Okay. Now it assigned an IP, and what you can do, we'll see if this pops up. It might not. We can come out and do later. So I clicked on the this, and then what I can do now is oh, sorry, I know what's going on. No, we'll have to find it later. I was trying to show you where, maybe it's right here, where you could actually go out and assign it its own IP. So here's it considers itself to be a Class C. So this is a classful subnet mask. So this identifies a subnet. This identifies this computer on the subnet. So basically what that means is my computer would have to have this same number right here, 192.168.0, and then dot, and then I can have anything in there between, well, we can't use 0 because it's reserved, between 1 and 255. So this is a Class C, which basically gives us 255 devices on our subnet. So see, we've learned all about this, and hopefully that makes a little more sense now. That a subnet mask basically tells us what part of this IP is the network ID, and what part of this IP is the actually node ID, or the actual device that needs an IP address. But if I wanted to change it, I could do what? I could change it here. I could change it over. So right now it's signed in a Class C subnet. So this is where you'd actually go once you get it up. You click on the little connection to the Profinet input, and then you can come back here and you can assign it its own IP itself. So if you needed to change the subnet mask and change the actual subnet, so we can close this all off. And now we can come up here. I'm going to close this up. And we should have, by the way, you can add a device right here. So you can go directly to the project tree, and you can add devices from right here. So if you added a new I/O card, then you could come in, and instead of running everything like that, you should be able to add here. So where's our program at? Yeah, program blocks. And of course, OB1 is the name 1, but we're going to rename this. So we're going to come up here. I'm going to bring up the testing station and see, and we're going to go ahead and build our subroutines. So what I'm going to do is I'm going to come out here and bring up the testing station and figure out what we're going to name OB1, and then what we're going to come up and we're going to try to put the subroutines in the correct order. It's going to take a little while, guys, to open. This is a big PDF file. So if somebody's not here, I'm not going to go back and re-record that, guys. So our program blocks. Okay. So we came in and we added each block. First of all, we renamed our CPU by right-clicking and then typing rename. By the way, if you wanted to go real fast, you could just hit F2. So this is the second function right here. And I think we got a lot of people are not familiar with a lot of the shortcut keys that's available with Windows as far as cutting and pasting and that kind of stuff. So I think I put that up there on there. You know, your control key is very, very important. It helps you do a lot. It's a lot faster than right-clicking and then going to copy and all that other kind of stuff. So Windows has a ton of shortcut keys that I can come in. Like I can go directly to the desktop without trying to close all my applications. So my applications are still up and running. So I think I've got those shortcut keys up there in your handout section, but I'm not really sure. So what we're going to do now, of course, is we're going to come over here. So what I did is I sent y'all all a message, and I said to send it out by email. And what I did is I attached Christian, so hopefully Christian's chart is okay. So I've attached Christian's tag chart to the email. So y'all can go ahead because y'all gonna have. I think I might be able to have both of them at the same time. But this is a very small screen on my computer that I use for my work. So what we're gonna do is we'll go to tags, and then we'll just go and open up the default tags. So we got another problem. So what we got to do is we got to set up our memory. Okay, so that's the next thing we need to do. So how do we set up the memory, those memory bits that we're going to be using? We're going to be using the timing bits, but more important, we're going to also be using that first scan. So right now we don't have first scan because if it did, it would already be in our tag chart. So anybody remember how we set up first scan? No, you're thinking RS Logic 500. So RS Logic 500 is S4, and then it's S:4/15. So it's built in. So we've lost, and this is the big problem, and this is what PLCs don't do anymore. They don't go ahead and assign all this memory inside your PLC. What they do is they let you assign it. So that that status register is already inside there, whether you use those timing bits, whether you use first scan, whether you use any of that stuff. So they sacrifice that memory in RS Logic 500 to get access to those features. Your new PLCs don't do that. If you want those timing bits, you got to enable them. If you want those first scans, you got to enable them. And that kind of stuff is hard to find. When I was taking my when I was doing my distribution station just to see if I could figure this out, you wouldn't believe how long it took me to find out how to enable this first scan. So now that I know how to do it, this might be a little note that you need to take, because that first scan is very, very popular, because what that does is when you turn this PLC on, it gives you the ability to set up your line the way you want it to start from. And you might only use it once. If you keep your PLC on 24/7, 365, then that would be the only time you would ever do it. But if you turn that PLC off and you turn it back on, then what you would want to do is you want to set the line up in the original position, right? So that first scan is very, very, very important. So what we do on the Siemens, yeah. On RS Logic 500, because on RS Logic 500 all this stuff is built in, because they set up all this stuff for you. So that means this status register on RS Logic 500 is already there, and they sacrificed that memory even if you never use. So in PLC 1, how many times did you use first scan in PLC 1? In Intro to PLC? Never. Yeah, but it was there. I mean, so they sacrificed that memory. So we don't get that on Siemens PLCs, and we don't get that on RS Logic 500 unless we enable that feature, and it'll come in and it'll assign that to some of the memory out there. So you're right. So over here, I'm back on RS Logic 500, and then I would come up here and I would create a new program, right? I still can't get my computer to connect to the PLC. We'd come in here and we'd find the PLC. So I've got 1100B. And then I would come over here under status, processor status. And this is what y'all keep trying to tell me. You keep trying to tell me this right here. So this is already assigned. So all this stuff right here, it's eat up all this memory right here, whether I use this stuff or not. So what we're saying is it's so force. So I've already got a force table built up. Well, in Siemens, you don't sacrifice all that force information unless you enable that feature. So we'll try to show y'all how to do that, because that force feature is a really neat feature, because that gives you the ability to check things out without having inputs wired up to your PLC. But remember, if you use that force feature, you're overriding the safety features built into your system. So you got to be really, really careful with that. So y'all saying this right here, but this is not Siemens. This is RS Logic 500. Here's that free running clock. Okay. So what we got to do is figure out how to do it over here. Okay, because we've done it a couple times, but we'll go back and do it again. So I'm gonna come up here and I'm gonna right click right here on my CPU, and then I'm gonna go over here to properties, and then I'm gonna come up here and go to system memory and clock. I'm gonna come up here, I'm gonna enable this, and then of course it's gonna put it in memory byte 1, but memory byte 1 is being used already. So we're going to shift this up to 6. I think we'll go all the way up to 5. We're going to put this at 6, and this gives us all our timing features. I'm going to come over here and click on that, and we're going to put this at byte 7. So see, before we didn't have this feature, and this memory, so these 2 bytes of memory were not assigned, which would leave me, so these are all memory bits. So my first scan, I'm going to use M6/0, and that should have been on your tag chart too, this first scan. So this is what you got. Yeah. So what I'm going to do is I'm going to say OK. Right? And now what we have to do is we have to update the CPU, the CPU. So I'm going to do the same thing. I'm going to go down and download the device, and then we're going to download the hardware configuration. So remember, we had to do this. If you remember, when we first put the I/O module on there, the green light was sitting there flashing. It never would go off. It didn't come on solid. And why? Because the CPU did not know it was there. No, this should be a lot faster, guys. Yeah, yeah. So what? So what we do, download new hardware configuration. As soon as I selected that, then this popped up here. It went out and found my CPU again. Then I'm gonna load it in there. Or try anyway. Okay. And then it's so now we should have those memory bits available to us. And we know what cat compiling is, right? So stop all. What's compiling? Yeah, converting it from ladder over to machine language for the PLC. Good. And then we're finished. So now we have access to the memory. We have access to the first scan. So we should be okay. So what we'll do when we get back on that EM Blink way back over there at the very end, what we'll do instead of using those cross-coupled timers to generate that 1 hertz signal, we'll just use the 1 hertz clock off of this thing. Okay. So did y'all find? Did that come to y'all, the tag chart? Should have came through your email. Oh, really? Okay. All right, I understand that. Well, I sent it through. I sent it through a message, but I also emailed it to you. So if you go to the message, you should have it there. Yeah. So if you go to message, you should have it there for the class. Okay. Or if you check your college email, you. Okay, good. So y'all gonna have to call these tags out to me because I'm using my laptop, and y'all know how big the screen is on my laptop that I use in class. Yeah, and why? So this is what we would. Well, what we'll do. Why do we want the tag chart set up before we do the program? Yeah. So what we'll do after that? So, yeah. Oh yeah, because then once we get the tag chart set up, we start writing our program. All I'm gonna do is look at those green names at the top, and I'm just gonna type them in, and then it'll pull in all our IOs, all our memory bits, all our outputs. It'll pull all that in for us without me trying to figure out take uh, these addresses and try to translate them over to my addresses, right? You understand that? So once we get the tag table in there, then all I have to do right here is say what? All I have to do is say EM stop, right? In fact, we got to figure out this tag. This is a timer. We'll have to sign some of these extra. So let's go all the way back up to auto. So right now, all I have to do is type in what? EM underscore stop, and it'll fill in what input we assign to it. So like our PLC does not have an input 0/13. And then all we'll have to do here is just pull this EM stop subroutine over, right? Just pull it in and we'll be through. So let's go ahead, since we've got that in, let's go ahead and go to our tag table. So we go here, then we go down to tag, and we go down to default tags. And then our memory tags are already there. Oops. So what I can do now is I can come down here and type and add new tag. So what's our first tag? Okay, EM underscore stop. Okay, then that's going to be a ones and zeros. Then we'll come, I'm going to hit enter, Rich. Oh, sorry. The P didn't. Somehow I deleted the P. So let me go back and edit that. In fact, let's go down the tag chart. That'll make it easier. So let's go down the tag chart. So what's our first thing in the tag chart? So all we're going to do is just go right down the tag charts. We're going to start on the left-hand side. I thought it had it open, guys. Let me open it back up. Yeah, steps. But then we'll have to assign those to all to the memory that I designated over there. So so you're right, Tyler. So we're doing Christians, right? Or Mr. Crows. And then we'll, I hope it is too. But even if it's not, so what we'll do toward the end, of course, is we'll take our module over there. We'll wire it up. We'll take our module over there, and I'll bring my cameras over there. We'll hook it up, see if it works. We know it's wired correctly because we were able to use the inputs and the outputs that's built into the PLC. So all we'll have to do is just move it over to the Syslink. Yes. I might not either. I gotta wait. So no, we're not going to use B3. We're moving from the B3s over to the S7s. So get away from the B3s. There is no such thing as a B3 in a Siemens file. We're going to move over to S7 and then that M. So these are memory bits. So M0.0 is what will be our first tag. Once I get this thing to load up. I guess I should have loaded the Excel file. Oh, it's here. I'm sorry. Nope, that's not it. That's the program. So we're not going to go by this program. That's what we did on our tag charts. What we're going to do is go by our tag charts, enter all the tags, and then we'll come back and do the program, right? Does that make sense? Okay. Okay. So I was trying to get the tag chart there. There it goes. Okay, so here's the tag chart. So what we're going to do is we're going to come down this line. We're through with this. This is Allen Bradley. We're over on step 7 now, right? So what I'm going to do is I'm going to come up here and do what? Do this M0.0, and the name is going to be this name right here, which I'll have to call out to me because I can't do both of them. So I'm going to come back over here. I'm in my tag table. Is it just step 1? Does it start off with something? 0, 1. Okay. And then what we're going to do, once we do that, we're going to move over to here, and we're going to assign that to M0.0. Then I'm going to check that off. We've got our first tag. Then we're going to add another tag. What's the name of this tag? 02. Right? Then I'm going to, okay. Then I'm going to come over here, and I'm going to, now notice what it did for me. It went ahead and assigned it the next consecutive. So I didn't have to do that. So this is going to be pretty easy now. All I'm going to have to do is enter. See, it automatically assigned it to 1, and that's what's neat. So I'm going to come down here on the next one. What is it? Okay, 03. Hit enter. 2-step. 04. Y'all see it's took all it's figured this out now for me. If I could come over here and change it, but as long as I just come right down the line, it's going to assign these right down the line for me. 2-step 05. 2-step 06. 2-step 07. 2-step. Well, then what we'll do is you need to give me, yeah, let's see. If it don't, we can figure it out, but it should. We'll see. So this is 8. Now that's the last byte. That's the last one in this byte. Let's see if it goes to the next one. Okay. So this is 2-step 0. Oops, Rich. Okay, so let's see if it goes to the next byte for us. Sure did, didn't it? 2-step 10. 2-step 11, right? 2-step 12. So let me move this down so we can keep our chart up here so we can see. 2-step, oops, 13. Oh, 2-step, Rich. And we can always come back and edit it. So I can come back if I make a mistake. See, I can come back up here and just double click on it, and it lets me change that. And also it lets me come over here and change the actual alias over, or the address. Is that right? 14? Any more? Huh? So this is 2-step 17. Okay. So what we did is we've used up our second byte. Okay. So we needed to change these over because do we have a second byte on this thing? Oh, it's memory. We're fine. So it automatically went to byte 2. Then we have an 18. Is that it? Okay. So what we're going to do now is we'll move over to this second one over here. Okay. Yeah, we're going to have to do the F start. Now, you say, well, why didn't we just put it right there? Because what happened, remember, they use the same setup for all the different modules. So some of y'all, these steps actually went all the way down into here. So we're going to have to go up to byte 4. So let's see if we can figure out how to do that. So down here, what's this called? Underscore start, right? Okay. So what I'm going to do now is I'm going to come over here and I'm going to click on this. And this is actually out on byte 4.0. What's the, okay. So now it should start addressing from here. I enter that. Okay, so what's the next thing in our tag table? I what? T? Uh, oops. Yeah, that's the initial position. You're right. So this tells the this will be a contact that'll close or memory. So these are going to be memory coils, guys, or it might be a memory input, but this is going to this is the signal. This is the I'm sorry. The program figures out if the line, according to the sensors, if the line is if the module is in its initial position. Is this 4-1? Okay. Is it 4-1 for initial position? 4.1, excuse me. Okay, what's the next tag? Is it 4-2? Even if it's not, I mean 4.2, excuse me, guys. And then what's next? Underscore N, like this? Okay, I got you now. Oh, crap. And it's 4.3. Okay, what's next? Is that it, guys? Everybody agree? Okay, is it 4.4? Okay, what's next? Is it 4.5? What's next? Like that? Is that okay? Like I said, if we make a mistake, we can always go back, right? Okay. Well, what's next? Underscore Q? No? Okay. Like that? Okay. Okay. 5.0? Okay, so what we're going to do now, we've entered this, This is set up for us, so we're ready to move over here to our inputs and our outputs. Okay. All right. So this you can see this is not hard once you got those tags set up, and it's really easy here because they're giving us the tags themselves. So what I want here, guys, I want what? Our first input. What's it called? Part available. So I'm gonna go over here. I'm gonna move over to here, and I'm gonna shift over to, instead of M, I'm gonna choose input. Yeah, for I. And is it 0.0? And then now it'll start following this sequence for us, right? Okay, what's next? Is it underscore B2 or just B2? Okay. B2 means it's a sensor. Okay. Okay. Input 0.1, right? Okay, what's next? Okay, what's next? Just B5 or underscore B5? Just underscore B5? Okay. What's next? Let me shift down so we can keep up so it don't keep me at the bottom all the time. Okay. So what's next? Okay. 1B1. Okay, what's next? Next. 2B1. Yeah, I understand that. So we might set up a rotation type thing, right? Underscore 2B1. Okay, next. 1P. IP underscore what? I got it. Underscore what? F? Is that right? That's a I. F1? Oh, FI. Okay, got you. That's okay. What's next? I'm glad you're involved. Okay, so it should automatically go. So it should be input one dash 0, right? Okay, what's next? P underscore stop. Okay. Yeah. No, that's me. That's not you. I'm just telling you what button that belongs to. So it's not the start button. So we're right here. So Crow. So Crow didn't look these up. These are mine. I'm just telling you this is the start button. So let's go in. I think it. Yeah. So here it is. Okay. Yeah. So what I yeah underscore S1, right? And then the stop button. Start emergency stop in cycle. So here's a stop button. It's underscore S2. You okay? So yeah, underscore S2. Yeah, so this is. Oh, she wasn't talking to us, was she? Underscore S2. Okay. And then the next one's underscore S3. Yeah, what I did, and I'm sorry I confused you. I thought I explained to that, is that these are the actual buttons on the front of the panel, and they're labeled stop, start, and that kind of stuff. And then we got another one, uh, yeah, reset. So what's next? Yeah, what's next? Yeah, okay. No, just that's fine. And this I can understand this, and of course all this would have came up when y'all were actually writing the program, because what you'd have happened is you'd have come over here in your program and you'd have typed in S1. I mean, you'd have typed in stop, and it would have came up and it would have turned red because it couldn't find that tag, and that would have gave you an indication. Yeah. So that would have gave you an indication that you have not identified that tag. So what I did here is I wanted to show y'all what these. In fact, I should have done it here, right here. This is the manual auto switch. It's a keyed switch on the front. That would be that guy right there. And so, but I should have done a little better on that guy. So that's okay. So what we can do now on our tag table is we can move down to our output. No, we're not through. We got to come down here and get this, right? Yeah, the e-stop. So I'm gonna go back. Let me go back to my tag table, and we'll do e-stop. Is it actually called e-stop? Let me make sure. It's called em underscore. Yeah, right. Good job. And then it's not 4. It's going to be 5. So we'll come down here and skip over this and just call it 5. Yeah, this pops up what you want to do, and then when you click on the arrow right here, you identify whether it's going to be a memory. It's going to be a memory bit, it's going to be an output, or it's going to be an input. And down here, this is the byte number, and then this is the bit number within the byte. So they just say address, but that's the byte number right there. Okay. Okay. So what we can do now is we can jump to our outputs, guys, and we've almost got our tag table done. And once we get our tag table, what we can do when we write our program is we'll go ahead and draw the rung out, and then I'll come back and do what? I'll just type in em underscore stop, and it'll pop that in for us. We know what this is. I'll just type in first scan. I think it's first scan, and it'll pop that in for us. That tag is already defined, and I think that should be in our tag table already. Yeah, so there's that tag. So it's already got that tag for me. So I'll put in first scan, right? And so let's go back down here. So we're moving to our outputs, which are cues. And what's the first tag there? What? Yeah, when we set up our memory, when we set up that memory, it added the first scan and it gave me the tag. So over here on our program, instead of putting this stuff down there, I'm just going to type in first scan, and then it'll pop that in for us. So that's something we have to remember, right? Because we don't have a first pass, and it's not right here. So when we get this first rung, we'll type in first scan, and I'll show y'all that when we get to actually entering the program, which will be after the break. So when we finish our tag table, we're going to come in and take a break. But I wanted to show y'all, once you get this tag table set up, then you're going to be programming by name. You're not going to be programming by addresses. I don't have to know that em stop is going to be assigned to that input. I don't have to know that. Just going to type in what? Em stop. Yeah. Okay, so what's our first output? 1M 1M1? Are we okay? Okay. Okay, then we'll come over here. I'll click on the down arrow. And so I'll come over here. I'll select Q, And then we'll come down here. This is going to be 0.0, right? And I'm going to come up there. And now I'm going to hit enter. And now we'll be able to go in order. We'll have to skip down a little bit here at the bottom. Okay, so what's the next output? What's the tag? Now I can just hit enter. What's the next one? I'm waiting. No, y'all don't want to talk over. Next. Some IP underscore what, Tyler? Okay, so we're going to come up. Okay, so we're going to come up here and go to Q0.7. Hit enter. What's next? What's that? What? Is it going to be Q0 1.1.0? Okay. What's next? It's going to be 1.1. Okay. And we'll come back and double check this. I don't know if I can print it off and send it to you or not. We'll see if we can do that. I think we can, but we'll figure it out. Next. Waiting. Somebody. What crashed? What crashed on you? Okay, let me go back and. The screen's back now? Okay. P4, I've got Q1.2. Okay. That's right. We've only got. So I'm going to come over here. We're moving over to our module. So that's 8.0. I think next time I do this. Yeah. So we've only got. Yeah, we've only got 10 outputs on this PLC, so we moved over to the module. Okay. Next. Okay. And it's okay. Next. So our tag table is complete. We think we might have to come in here. We might, yeah. We'll probably have to add. No, I don't think this might be it because when we set up timers, we'll give a timer a name. But we'll do that when we set up the actual instruction itself. So guys, let's go ahead and take our 15-minute break, and then we'll come back and start our program, okay? Here. All right. So we're in PORG, and we're ready to start. So we need to start pulling this. Now, here's our instruction palette, and by the way, if we need to add things to an instruction palette, if I remember right, I know we do a lot of on delay timers. So I'm going to come down here on my on delay timer, on. Yeah, I'll make sure. So you notice what, y'all see how I did that? So I just went ahead and pulled the T on over here and put it into my block. So that's so much easier. I'll try to show y'all next class how complicated it is to add stuff to RS Logic 500 to your most used palette. I think we're going to use the P-Edge. So those are up in bit files. We use quite a few of those. So I'm going to go ahead and we're going to use the P edge trigger. We'll go ahead and drag that into our palette because we use that quite a bit. And we use the compare, I think only, I don't think the compare's here. So I think this is all the instructions we'll need to make it easy to program. And I'll have to show you this, guys. This is really, really cool when we get along. See the one with the question marks right there? That's really, yeah, that's really neat. So we can, if we learn the mnemonics for each instruction, what we can do is we can come in and pull that down and just start typing this, and it'll pop the instruction in there for us. So basically we could program the whole thing with that empty box right there. It's a lot easier like in math and stuff like that where the instructions get more complicated. So I think we got almost everything we need up here in our palette right here, so we won't have to go over here to our instruction set a lot. We'll move, oh, I'm sorry, we need we use this a ton. We're going to use set, and we're going to use reset a lot in this. So instead of so now it looks like we can close up our instruction palette over here. We've got examine if open, we got examine if closed, we got examine if open, we got an output enable, we got our down and up, on delay timer, P trigger, set and reset, which I think is the major portion of what we use in here. So we can go ahead and close this up, and what it does, it gives us more room to see this. So let's see if I can, yeah, split the screen, and then we'll come up here and bring up our program over here. Where did it go? Huh. So let's try that again. So we'll close it. And then I'll open it back up. You're right, it did. It went into the abyss. Yeah, I know, and it takes a little while to open up these PDF files. So PEM stop, we'll pull that and just pull it into our rung, which is really neat. Yeah. So here's, we're set up. So now I can come up here and I can type in EM stop, right? EM underscore stop. And notice it popped up there. So I could come down once I start that. And then I enter that. And then down here, we're going to type in first scan. So I started, there's first scan. And then our first rung is finished, our first network. So remember, we're always going to be one network ahead because RS Logic starts their rungs at 0, and then the Siemens Simatic S7 starts their networks at 1. So we'll always be one ahead, right? So we'll come down here to the next one. We're just going to pull in our EM blink. So it's unconditional. They set the conditions inside the subroutine itself. So we'll open this back up, grab EM blink, and then pull it in. it's going to tell me, does it want to add this memory block to my program? And we're going to go ahead and say OK. We can close this back up. So we're through with the first two rungs. We come over here, we go down to rung number 2, which would be network number 3. So every time I enter one, it automatically puts the next one on there. Here we're going to use underscore S2. So we'll go ahead and pull this down, and we'll type in underscore. It should pop them up. Underscore is probably down there, S2. There it is. Hit enter. It automatically brings that in for us. Then we're going to bring P stop, P underscore stop. I think I put it in the right one. Like I said, I'm having to cover up my network a little bit. So this one's set up. Then I can come down to my next rung. And I'm going to need a normally open contact. I'm going to need another normally open contact. And then I'm going to come over here. I need a coil. Underscore 1B1. Under 1B2. Yeah, 1B1 and 2B1. Thank you. Yeah, I see that. Thank you. 2B1, and then our output is INT. So INT, initial position. See how that pops up? So as soon as I typed in I, it automatically showed me all the tags that start with I, and we could go ahead and so. Okay, we'll go back and correct that. Oh, sorry. Let me enter this one. So underscore 1B2, right? So that's correct. Okay, so we come down to the next rung. Next network over here, we're on 4. Over here, we're on 5. So I'll come down and I'll pull down 2 examinative close contacts. And then I'll pull down another. Huh? Yeah. Yeah, it is. It's a latch, so we're going to use set up here instead of the regular coil. So this is underscore S1, right? And this is INT, initial position. And then this is F underscore start. Yes, so that's the difference. So here they call it set. So set, unlatch. So for every set, somewhere we're going to have a reset for this one. Okay, guys, does that rung look okay? Okay. So we're on rung 6, so over here we'll be on 5. So we'll have to come over here and we'll pull down a normally closed or examine if open. Then we'll come over here and we'll put a down drop, and then we'll come in here and do a normally open. It's hard for me to see, guys, so I've got to take care of me because I've got my little tiny screen. Then a normally open, then an up, and then we're going to do an unlatch, right, or a reset. That look okay? Yeah. Yeah, I know, Tyler. You're on the phone. So here's EM underscore stop. Is that right? And down here, this is. Okay, hold on. Let me. Mine is thinking. And down here, this is cycle end, CY. And just now I typed the second letter. We had a bunch of C's, but as soon as I typed the second letter, that popped up. Then this is underscore S3. Is that right? And then I'm doing an unlatch F start. Okay, so we're down on the network. This is where we're going to use our P edge. So we're on network 7. So over here we should be on rung 6. Oh, that's a normally closed. Normally closed. Then we put a down drop. And then I have a normally open. And then I come up and put another down drop. And then I have a normally closed. Then we put an up, and we put an up, and we close this thing up. I like it because this looks a lot like relay logic. You know, over here on the Arch Logic 500, it does this kind of thing, which looks weird. So here we're going to use our P edge trigger. Okay. So this guy right here is underscore S2. Is that right? And then we have F1. Is it F1 or underscore F1? Okay, that's first pass. I'm sorry. So this is first pass. So here I'm going to put first scan. And then down here, this is EM stop. And we have to sign a. So which one was B32/4? What do we call that? P edge 1. That's okay. Yeah, P edge 1. Okay. So that's network 7. That's rung 6. So we're down on the next network. So over here we'll be on rung 7, which should be network 8. So this is a simple one. here we have a set, right? And this is P. Let me go back and double check. P edge B Q1. B36, B36. So this is the one we just called up here. We just called it P edge 1, so that'd be okay. I was looking to see which one of these was up here, but we don't have that output bit because we have the Q output. So we need to do that. So that's what we need to miss. So I got to bring a coil down here. And this is where we're going to have to figure out which one these are going to use, and we're going to have to remember which one. So this is probably going to be, in fact, I know what we're using. We're using P edge Q. Okay. Which would be the output bit. So here we should, since this is the output, which is this guy, then we need to use P edge Q1, which is what's out there. It's a Q, yeah. But we didn't, some reason we didn't set up this. In fact, I think I gave y'all these symbols. I mean, I gave y'all the tags because on ours, on RS Logic 500, it has a storage bit and then it has an output bit. And notice it don't have a coil over here. Well, on SIMATIC 7, we have a Q output. So what we do on this one to monitor the output, we'd use B3/6. Well, what we do on this one, we have to put a coil on here, and we assigned it to this address right here. That makes sense. So this is Q, and so we're going to use Q here because we're monitoring B32/6. So this one is looking at B32/6. So whatever we assign this output up here, using an output coil, right, but this output right here. So then we have this set. This is a latch. I have a set. And then we'll come in, and this is going to be 2P01, right? Yeah. And then we're going to JSR to back. We're going to JSR to P auto. I'm going to swing this back up here, grab P auto, put it down. Say I'm going to insert this data block, and we just finished up. We just finished up P. That's the end of OR, yeah. Yeah, so we get into P auto. So I'd have to. I got it shrink down so far, but they should be in the right order. So this would be P auto, and now this is the long program, right? And then I go ahead and pull down this. This uses a bunch of set and resets as it goes down through here. Oops, this is testing. This is PORG. Yeah, it is. Because if you followed it down here, it's going to go through the sequence. So you latch it, then probably on the next step, when a sensor goes true, you unlatch it. And so if you follow this down, and we actually figured it out, which we don't have time to do, that would take a lot of times, because we'd actually have to bring up the diagram of the PLC and see which one of these outputs in which one of these sensors. So so first of all, we need a normally open, we need a normally closed, we need another normally open, and then we need another normally closed. So y'all have to watch me on this one. Then we need a set. Then we need a down drop right here, and then it didn't come in. Then we need a reset, and then we need another down drop right here, and then we need another set. So over here it's going set, reset, set, right? Over here this is EM stop. Over here this is toggle. This is two-step 01. This is reset OK. This is two-step 2, right? Oops, sorry, Rich. Two-step 2. This is two-step 1. This is toggle. So we're going to latch the toggle from here. So this saves us all these seal-ins and that kind of stuff. So you can see this is very, very popular to do that. And we're just going to step this down. So does this rung look okay, guys? Tyler says okay. Everybody in agreement? So see how easy it is? Yeah, see how easy it is now that we set up our tag table. So instead of trying to know all these addresses and all that, now we can just come straight down this thing. We can just come in. We can go ahead and set up our rung first, and then we come in and just do what? And then we just come in and fill it in. So this is network. This is rung 1, which is on ours is going to be network 2. I'll pull in a normally closed. I'll pull in a normally open. I'll pull in another normally open. I'll pull in another normally open. Y'all got y'all's blown up a little bigger, right? So y'all can help me. Then I come over here. I pull in a latch, which over here would be set. I put in a down drop. By the way, another thing that they don't show is they don't show the L2 side. I guess y'all noticed that because they take for granted you know it has to be there, right? And we don't do anything over here anyway, so we don't make this connection over here, even on RS Logic 500, because everything's got to end with. So here we've got in a set. Here we're going to have a reset. Here we're going to have in a set. Up here, this is going to be a normally closed toggle. This is going to be initial position. I think these first two are looking for that, right? This set here is going to be two-step 1. This is going to be reset OK. This is going to be two-step 4. This is going to be 2 step 1. And this is going to be toggle. So this is network. Oops. So this is network 2, which over here would be rung 1. So does this one look okay, guys? Okay. And this is why it's nice when y'all set up in teams. And what we would do if we were there, we would do what we call 10 rungs. In fact, guys, I'm going to come up here, and just to be on the safe side, I'm going to come up here and I'm going to save my project. In fact, I should have used save as, because what happens every once in a while, this TIA portal locks up on you, and we've had people lose, 10, 15 rungs. So normally if we were in class, every time y'all swap team positions, then what we would do is we would let you save it, and we'd put a save as, and we'd call it, 1, 2, 3, right? Y'all understand that? And in that way, if you wiped it out, you could always go back and you'd only lose 10 rungs. So it's just like any computer application. Computer applications give you problems every once in a while. We've had it happen more than once where a student have all these things programmed and they didn't back up and it locks up on them. They have to start it over and they lost everything. So that's a good habit to do even with RSLogic 500. If you're dealing with these very complicated, you need to save it, and you need to save it under a different name, and that way you can always go back 1 or 2 spots, right, and to pick it up. So that's always a good idea. And then when you get to the end, you can delete all those backups if you don't have a bunch of disk space. So over here, I'm listening. Hey, Kristen. Yes. Yeah, that's why I say y'all got to help me. It's really hard for me to see this. 6. Good, good. So this is 6. So that's the kind of stuff we need to do. What I'll see if I can print it off and send it to y'all, and then that way you can double check to see if we've got something. Because guys, it's extremely hard for me to see this stuff over here on the left hand side. So thank you. Does it look okay now? Oh, oh really? Okay. All right. So we're okay. All right. Yeah, this is too over here on the left hand side. On mine, it's a little blurry too, so I don't know what's going on there. But so we go down to rung number 2, which would be network 3. We're going to pull down a normally closed. We're going to pull down another normally closed. We're going to pull down a normally open. We're going to pull down another normally open. We're going to pull down a set. We're going to pull down a down drop. We'll go down and go ahead and pull down the other down drop. Then we're going to pull down a reset. Then we're going to pull down a set. So see, now that we got our tags, what we're doing is just go ahead and you're doing what? Just creating the rung, and then, yeah, and then we're coming back and typing this in. So this is underscore B4. Yeah. This is toggle again. So toggle is something very, very important. So notice toggles in just about it's in every rung, right? Then we come up here. This is underscore S4. This is 2 step 2. This is 2 step 3. Is that right? I can't hardly see that, guys. This is 2 step 2. And this is toggle. Okay, that's it rung, guys. This is network 3, which should match rung 2. So look it over and see if it looks correct. Yes, Brianna. Yeah, no, it's like I said, it's blurry on my screen too. Let's go. Let me go out and instead of opening up the whole program, what I'm going to do is just go out and open up just this is network 3, which should come over here and match 2. Oh, this is still 4. Here's 2. Nope. Let me get down in the right subroutine. So this is it right here. Okay, guys, I'm ready for a 15-minute break. Are y'all? All right, we're gonna take. Oh, really? Okay, so guys, I need a 15-minute break. Okay, so let's take a 15-minute. So we're doing network rung 3, network 4, and we pull down the requirements for it as far as our inputs and our outputs. Our output instructions. These are not actual output ports. And we start off with toggle, right? Then underscore 1B2. Oh, underscore, Rich. No wonder it didn't put, yeah. Underscore 1B2. Then 2 step 3. 2 step 3. 2 step 4. 2 step 3. And then toggle. Okay, so this should be network 4, which should be rung 3. You'll look it over and see if it's okay. Everybody agree? Okay, so we're going to rung 4, which would be network 5. Yes, it does on delay timer, so we'll see how that works. It's set for 1.5 seconds, which would be 1500 milliseconds, but we'll show you how we can actually enter it in seconds. Y'all okay there? Because we take 150, multiply it by 0.01, that would be 1.5 seconds. So all we got is a normally open. And then we got an on delay timer, which we've already put it in our most used palette there. We're going to call this timer 1. So notice it gave it a name. We're going to call it timer 1. Oops. We can't put a space in there. So we'll just have to do it like that. Don't like a space. So this is going to be timer 1. And here's our Q output. So what we're going to have to do is we're going to have to assign a coil to this done bit right here. So we'll have to figure out, but it's going to be an internal coil. So this contact is going to be step 2, step 4. Is that right? Okay, and we want 1.5 seconds, so I'm going to put 1.5, and I'm going to put an S here. And it should take care of that for us. Yeah, we're not going to monitor the elapsed time. So what we got to do is we got to assign this a bit file that is not used. So we need to go into our tag chart and assign a memory coil that is not being used and put that on our tag chart. So I'm going to bring up our tag chart. Well, we've got the whole tag chart. So we've got all the memory bits that's already assigned, right, to all the step files and all that other kind of stuff. So all we got to do is just find one that's not in our tag chart that we got a hard copy of. Understand, Tyler? Yeah, because we've got everything. Yeah, that's what we're going to do. So that's why we got all those spaces down there. For one thing, some of the lines require more memory bits, but every time we're going to end up with some, and we can go all the way to M dot 065,535, guys. So I'm sorry. We can go all the way from M 65,535 dot 7. So we got plenty of, and you notice, yeah, so we got plenty of memory out there if we need it, as long as we don't run out of memory in the PLC, and we're not even close to this, and we won't be close on any of these programs. So that's one thing that we'd have to work. So yeah, as long as we don't run out of memory in the PLC, we've got more memory bits than we'll ever use. So we got 65,535 bytes. We got 65,536 bytes because the byte address starts with 0, right? And then we got all the way to 0.7. So you notice I've even got blank on the back. There's the actual tag table, which I didn't send y'all, but when you did your tag table, it was actually 2 sheets, and the second sheet was just totally blank, so we could fill it in with whatever we needed to put back there. So what we're going to have to do is we're going to have to look at our tag table, and we'll assign it now. We'll go into our tag table and we'll assign it, and then from then on we won't duplicate it if it's in our timetable, right? I mean in our table. So let me bring up our and see, we'll assign it, and then I don't have the type of one, guys, so we'll have to do that. So y'all have to do that for me. So because, well, maybe, yeah, I think Kristen sent me the Excel sheet, so I'll use that one, and we'll assign that. Yeah, so he used this. So we've got all these that are unassigned. And then before we do anything, we're going to go into our tag table because we're going to have to use this output sooner or later. And the tag, we'll call it timer 1 and actually give it that tag. And then that way we shouldn't have any problem with this as soon as this loads. So if we run into so the next time we run into a timer, we're going to have to assign it a what? Well, we're going to have to assign it a coil. I think all these use memory coils. What's that? Yeah, we don't that's internet. We don't need enable. We never ever use that, so that's just there. We do use the timer timing, and that every once in a while we use the timer timing, and so these timers don't give us the timer timing. Basically, it gives us a timer done, but we could use that elapsed time and to figure out how to come back in more advanced instructions, which we're not, got into to simulate a timer timing. So it looks like we got M2.2 free. So we're going to assign this to timer 1. And then what we'll do is we'll go into our tag chart so we don't forget. So we'll come back and we'll pick up our tag chart. And then what we'll do is down here at the very bottom, right here, we're going to assign we're going to call this timer 1. And then we'll go here and assign this to memory bit. And we're going to assign it to 2.2, right? Okay. So now we've got that tag added. And I knew this was going to happen, right? And then, okay, so we've got the tag set up. So we can close out our tag chart. And then now we can come over here and just type timer 1. Oops. Well, yeah, but it should have been let me go back into the tag chart and look at that, because timer 1 said there was nothing there. Oh, there it is right there. That's the data block. So that's the actual data block here. This is the since it already assigned that to the data block, then it had to put this one out there. But that's still okay, guys. So it did it for us, right? Okay. So we got that. So we got it set up for, we're looking at, let me close this guy out and I'll leave it in the background. And then I'll bring back up my chart. So we've got set for 1.5 seconds. We're not using the elapsed time. So the Q out is like the timer done. And this is going to be timer 1 in parentheses 1. So it'll pop up. So when we set up the timer, it set up a memory block that's already got that tag right there. So that's why it automatically put the parentheses around it for me. So it took care of me. So we okay? That look okay? Yes. So we're not using elapsed time. So we're just going to leave that blank. This shows me the time. So time is 1.5, and S means seconds. This right here is two-step 04, and then we've set up a new tag for this timer called timer 1, and then 1 inside parentheses. So it automatically did that for me because this was already assigned. Okay? So we're going to go down to rung 6. Rung 5, which would be network 6. I need a normally closed. I need a normally open. So this is where the timer is going to come in. So they're doing done. We don't have a done bit. That's going to be what we assign to Q up here. We need another normally open. And then we need a latch or set. Set, reset, set. So this is toggle. This is timer 1, yeah, parentheses, good. This is 2-step 4. This is 2-step 5. So notice this says once this step has been completed, then we're going to unlatch that one, but this is already going to be set, right? Does that make sense? So we're going to the next step. So we're going to unlatch 2S4, but we got through, we set it, so it's okay to reset it. And then down here we're going to use toggle. Looks like toggle's just about on every one of these last ones, don't it? Yeah. So toggle would be false. We'd get in here. Timer 1 is timed out, so it's going to wait on 1.5 seconds. Step 4 has already been completed. It was the step before. This is going to come in here. It's going to set step 5. It's going to reset step 4, and it's going to set toggle. And then something's going to happen there. So the next one, toggle, is probably going to be a normally open in the next one, I would think. Yeah, if it's in here. Oh, guess what? It's not in. Yeah, no, it's a normally closed again. That's going to be interesting to see what they do to get through with this, because we no, we latched it here, right? So we latched it here, and then we'll unlatch it. No, we're latching it every time. So, which is interesting. Okay, guys, one more rung, and then we're going to call it quits for tonight. So we're on rung 7, which means up here, so did we do that right? So this is network 6. This is network 5. So this should be network 5. Toggle timer. Okay, so we're right. So here's network 7, which over here would be rung 6. Yeah. Which would be this guy right here. I guess that's a 6. We start off with a normally closed. Then we have a normally open. Then we have another normally open. Then we have a latch, a set. A set, reset, and set, which is pretty standard on every one of these. Okay, hold on a second. I don't know why it does that every once in a while. So we're doing rung 6, right? This is going to be toggle. What? Really? Okay. So toggle in initial position. Thanks, I couldn't read that. Initial position. Then step 5. Let me we should have been the previous step. So this step has to be completed before this step, right? And then this is going to be, we're going to set step 6. Yeah. So what we're doing is so this rung has to be through before this rung is through, and of course it's going to have to be back in its initial position. And then we set and get ready to go to the next step. Then we're going to reset this step. So we're going to reset step 5, right? And then we're going to come. The initial position, I don't know which one of these things it's looking for the initial position. I don't know if it's trying to look and see if the whole line's at the initial position. But we'll find out where this guy right here is actually controlled. So I don't think we've got to where this contact is actually coming from. So we used it a lot, but I don't remember actually seeing it over here on the right hand side where it said initial position. But we'll go back and look in a minute. So, and then we got toggle, which is usually the last one. Okay, guys, does that look like okay? Okay. So what I'm going to do is I'm going to try to see if I can print this off. I know I can, but I can't remember exactly how I did it. And then you'll be able to compare this, and that way y'all can go back and double check my work. You know, we got several eyes on this, but it's still no guarantee that we're not going to make a mistake. So we'll go ahead and call it quits for the night. Y'all got any questions? So I got one thing to do. I got to get y'all's test review up there, right? What about the assignments? Have y'all been doing the assignments? And those are on the calendar. So we have yeah, I know they get intertwined with each other, don't they? So it's especially when it's the same teacher, you know, teaching 2 classes, you get them. So we have I'm gonna go ahead and pause.